buildings. The other half of the audience said, yeah, nobody's out telling us about this.
Yes, and in an academic environment, where half your 800 million a year comes from people believing in the sky is falling, you have to be very careful. Before I go any further, Lucas, do you want, since you're not able to see the screen, do you want me to record this for you, or can we just not record it for you?
You don't have to.
Okay, good.
Challenging dilemma for a designer is, what capacity do you design for? What you know exists today, what is planned for the future, and what might exist down the road. So you can have a huge expense sitting there doing nothing. On the other hand, you could have a plant that's overloaded.
Do you have a load when you come into a plant? By the way, guys, I'm recording this for Bill. This is just too important for him not to hear it, and he'll look at it and he'll add to this. Don't you start from either an existing or a projected load? Don't you have a heat load to service or a cooling load to service? Don't you start from the knowledge of that?
Yeah, you have existing loads, but the trickier part that Larry's talking about is, what about the future loads? And most campuses are growing and adding buildings, and loads are changing over time. And how do you account for those?
Yeah.
So I think it's possibly that could fall into the advantage and disadvantage, right? So central plants may have you could potentially have an advantage in that it will be easier for you to service future loads, right? Because you can build your plant so that you can add in additional boilers, additional chillers, right? You could have header system. You could oversize your piping. On the other hand, it could be a disadvantage in the case that Larry's saying maybe you have to spend more now for that future load that you don't even need yet.
Well, that was a refinement. I asked this question in many disciplines, and I start with electrical, where you have there's general statements made that you should plan for the future. Of course, nobody knows what that is, and what ended up happening, at least in the case of electrical, is that plans for future capacity were not realized, because were not fully used, because we were more intelligent. We were using our energy more wisely. So back when the utilities were giving you incandescent light bulbs to increase their load, it was expected that was going to be, that it was just established orthodoxy. You're going to have 2 to 8% load growth. Well, it never happened, and it happened because we got smarter about how we used it. Meanwhile, we're sizing all of our electrical services larger than they need to be. And so I see with the structural engineers also, Mike, we don't want to take any iron out of our structural steel. Suppose our office building is turned into an armory where we have to put tanks. Well, wait a second. Well, that's a different project. And that's a different occupancy. So, and you're running it, and obviously we're running it with you guys. Whereas, yeah, you can assume that your cooling load would be a certain number of BTUs, but what you're finding is by the time you get the darn thing built, the economic use of the building, or the sustainability, those art history majors I make fun of, Larry, will come in and find a way to change behavior, and there'll be less use. Is anybody blowing out their design capacity that you know of right now? Do you have any anecdotes?
No, because in almost every case that I'm aware of, we over-design, sometimes by as much as a factor of 2. But then you have a situation where a college gets a grant to do science research, and they build buildings with 100% outdoor air, and 2 years later, when the grant expires, they convert it to office space, but they're still using 100% outdoor air.
Mm-hmm. So
and that's not right. That's sort of a separate issue. I mean, I think it kind of depends. That's where the art part of our business comes in. So,
but that's where the facts come in.
I mean,
and that's where we need to get factual data from colleges and universities that have done it to find out what their mistakes were.
Okay.
Yeah, but if there's infrastructure We're talking about general infrastructure and putting in infrastructure systems. And then in general, oversizing those systems has been a benefit to the owners over time because it's always less expensive to put it in now than to have to dig it up later. So of course, you don't want to have stranded assets or waste resources. So that's where I'm saying the art and balance come in. I mean, if I dig up your street, Mike, and then, to put in a bigger chill water line, I come, around 3 years or 4 years later, say, oh, we got to, loads of growing, we got to do it again. No one's going to be happy about that or think it's smart, right? You want to put in some piping that's big enough that's going to last, 20 years or so before you have to start thinking about it. I mean, I have some plants where we're still praising the original engineers that really thought for it when they put in those giant headers that lasted how many decades without us having to have to dig all that up.
Yeah,
right?
One of the other favorable issues is diversity that you can take with a central plant that you can't take with individual plants.
That's another advantage.
All right, I just wrote that out. What I'm hearing you talk about, Lucas, are buried pipes. Is that always the case on camp? And that's certainly not the case here.
I mean, so that's one example. So it goes to, well, how easy is it to add that infrastructure? Well, I mean, if the answer is you can add it any time, okay, well, don't worry, you can add it any time. Don't worry about it. If it's like, no, you need to plan ahead, and there's lots that goes into it, and once you got this street dug up, oh, by the way, you ought to do everything you can, so because there's a lot of cost in it digging up and the street versus the actual utilities themselves.
Or the debate between direct burial and tunnels.
Yeah, so there's, so I guess you get to have that debate with a distributed system. Like what type of utility system do you want to have?
Yeah, because once you build a tunnel, then you can have multiple services: heating, cooling, communication, power.
So, okay, that's with a central plant. What happens when you say the economics aren't there because of distance or whatever? Now you're going to satellite plants. So I'll tell you here at U of M, and you're welcome to use our campus as a system. We have about 6 of them. Dave, we have a system over by the School of Social Work. We have one over by the physics building. Where else in cooling system? So a little mini plant.
Campus, we have them over at the Life Sciences.
Okay, Life Sciences.
The East University chiller plant.
That's 4.
At the North Campus chiller plant.
Well, I was just do central. So 4. So we have our large, and we're doing about 600,000 pounds of steam. Okay, that's 5.
Another one at the
6.
6.
Okay. So that's good enough. 6, and they're supplying 6 or more buildings. Okay, 7. All right. So, but are they doing their own steam there, or are they taking steam from the powerhouse? Okay. All right. So of our 600,000 pounds that we're doing, that's all being distributed to these other mini steam distribution plants. Okay. That's in words. My colleague just happens to be in here. Thanks for the estimate, Dave. Oh, yeah.
But
okay.
a big debate in that area is whether to use steam or hot water.
Yeah, and also our rates here. So you're dealing with a problem. You're mechanical guys. You've got so many dimensions to your problems. That's why I never dealt. I didn't want to major in mechanical engineering. You use surfaces.
Too many different units, huh?
Too many. All those Reynolds numbers and all that shit I took in those fifth-ordered partial differential equations. Shit. Anyway, so yeah, being a lump parameter finite math guy, here I am. Well, I don't even know where to start on this thing. Obviously,
one interesting thing I think would be to we should have a discussion in this debate or paper or whatever we end up putting together is what do we mean by centralization versus decentralization? Because in my mind, it's a little bit like a fractal, and then like you keep zooming down, and like what was decentralized now becomes central, and I don't know if you were following me, but say
Yeah,
if you're back at the utility level, then having a power plant, a central plant, is decentralized. But if you zoom in now at the campus level, well, now that decentralized central plant now is central, right? And you can zoom down onto the building level similarly.
Yeah. Oh, I see. I see what you're driving at. Yeah. Scalability.
Well, the other dilemma that you face is that at almost any university, they are going to defend what they have because it's what they have, and they wouldn't look good to suggest that what they have is wrong.
Well, that's right. We don't have the normal price signals of the private sector, do we? Yeah, I struggle with this more or less hourly. Well, we are an incremental organization, industry rather. We don't take fast moves, certainly not with large amounts of money. Typically, our scenario, 80% of our situations are, we have another new building that has a heating and cooling load. How do we get pipes to it? That's and so the question, at least the way one question would be when a manager faces that, is the degree to which they should decide, do we want say just an independent electric, do we want to cool this electrically, or do we want to run steam from from our central plant to it? So the common decision is one: how do we add a building? Or and maybe less similar is how do we take an existing building that's being repurposed and re-engineer it so that it's economical?
No, but the other issue is how are the buildings funded? And if John Doe donates $100 million for a chemistry building, does he get more chemistry building or less chemistry building and more central plant?
Mm-hmm. Yeah.
And if there's a pipe infrastructure that's going out the street to serve one building, could it possibly serve a number of buildings, and could those number of buildings share in the cost of that infrastructure so that that one building isn't solely burdened with that cost? Yeah. Because sometimes that will kill it. Oh, I've got to put in 2 blocks of piping. It's going to be more than putting in a central plant for that building, possibly.
Well, I guess this you guys have redefined brainstorming.
Huh.
I can see 4 or 5 different. If you wanted to spend I can see 4 or 5 hour presentations. As I've told you, that I can give you an audience even before then, before you have a formal audience, right in your own, right at your own desktop. As I start to reach out and we develop our websites and outreach to other parts of our organizations, you understand that we are challenging the traditional let's go to a conference and tell our stuff story. We are bringing it out through YouTube videos principally, and this is a way for you to get you in front of possible clients, and of course you help me when you do that. So I don't know where to go here, guys. I can say let's get Bill in on it. Do you want to target a presentation to any of these organizations? Let's go back to IDEA. Do we know if IDEA is accepting proposal ideas? Lucas, you're closer to them.
Yeah, they're accepting. Well, I think they've already got their abstracts, but they may still have some. Their campus one's coming up in February. I think they've already had a call for abstracts. I'm not sure when it closed.
Oh, that was probably done a long time ago, if it's just for February.
Yeah, I mean, it closed recently. I think, again, let's get the outline of our presentation. Why don't you forward what we put together today to everybody, and then when my email and internet gets going, I'll jot some ideas, and let's touch base with like our final outline in a week or 2.
Sure. Let me see what a time slot looks like. So that time, Bill will have a chance to listen to what we've talked about here, and at any time, you guys are welcome to talk between yourselves. So let's first get a time slot. Then I'm going to go back to some data gathering resources we may have. So let's see. In December, I've deliberately tried to thin my schedule out here, and we're here And what does December? Well, that's Christmas. What does the 18th look like for you guys?
Open.
It's no good for me.
It's at what works for you guys?
Any other day that week is fine.
What? Say that again, Larry.
Any other day that week is fine with me, but
Is
the
that
18th
right?
is not good.
Okay. How about the 19th, Friday?
Yeah.
Friday at 4 o'clock, or is that all right for
1
you,
o'clock.
Larry? Or what? 1 o'clock? This meeting goes away for me now, Larry. So 1 o'clock would be. What works for you on Friday, Larry?
Any
time in the afternoon is fine.
Okay. So, but that would be so an afternoon. So if we were to just say, how about
so 10 a.m. my time?
10 a.m. 1 o'clock? Is that right? 1 o'clock?
Yeah,
10
that's
a.m.
fine with me.
10 a.m. West Coast time, 1 p.m. East Coast time.
Yeah. Okay. 1 p.m. then.
All right.
Okay. So right now we're calling. I'm going to just kind of call this a district energy project.
Session. Then yeah, send what you have or send us a link.
Yeah. It's a district energy project. Now stay there, guys. You'll see the visuals on this very shortly. So we're going to put this at 1 o'clock. 1 o'clock to.
No, at 1 o'clock Eastern time. There you go.
Yeah, and let's just say 1 to 1:30, and I'll try to get Bill in. So let's see. Okay, so here's so I'll do that. I'll send you the link, the update that I just made, which was right here. I think after a while, guys, I gave up trying to catch up with you. So I'll give you the recording, and you can listen to it, and Bill will listen to it, and you can jot down stuff. You're welcome to just send me a plain old piece of paper or an email, and like I did here, and I'll just roll some notes together. Of course, you'll have to ask your question. If you visualize how you're going to make a presentation to an organization, usually they want a 150-word abstract and then some takeaways, and you know all that stuff. So once you do that, then you can shop the thing around, or variants of it, depending what your audience, what your audience wants to be. I'll find out. Actually, I won't find out. Since you're closer, Lucas, you can find out when your deadlines are there. But I'm not. Since you're closer to them, I feel like I'm intruding upon your space.
No, there's no worries.
Okay. All right.
All
right. So one thing then to close this out here is that I have some money to sponsor a design project for Michigan State University, and so the students are looking for projects that that'll be a team of 5, and it's supposed to take a whole semester there, which I think is about 10 weeks, 9-10 weeks, and I believe these are seniors. This is their senior. I did one of these when I was in engine school also, so I thought of so I'm giving them some projects that I want to get done. Whether or not the students bite on it, I don't know. But if there's any data gathering, see what they want you to do is they want you some creativity to solve a problem. You can see. I'll send this to you so you can see what it's all about. So you can think of some projects now. Remember, this goes on 3 times a year. Okay, about every 4 months I get an opportunity to do this. So I can get a team of 5 undergraduates 4 times a year, and I have the money. It's only $5,000 per project, and I do have the money to support them. Except in this particular case, I have some political problems because I'm the driver from U of M, giving money to MSU for them to study their own power system. But since I was a MSU student in grad school, I can probably get away with it. So anyway, I thought I'd let you know about that.
A project of this scope is more appropriate for graduate students than it is for undergraduate students.
Okay, and that's fair. Well, when I'm working in this milieu with the gentleman who was it, Mike? Yeah. We'll keep that in mind, and also remember, I have access to the entire 1,500 universities and colleges, so it's just not like this is the only one I can work with. It's nothing. All right.
Well, get me the data on existing central plants or just existing college and university energy so that we can use that as a
Baseline. That's some base data.
Right, as a basis for comparison.
Yeah. Okay. So let's get Bill on that one. I asked him, Bill. Okay. That's this one here, right? I'll put that there in red. I'll put that there in red for Bill to look over for us. Did it go in red?
Gentlemen, if it's okay, I'm going to excuse myself. I got another conference call coming up.
Great. All right.
Okay.
Thanks for your time, guys. I'll see you on the Worldwide Inner Tubes. Yep.
Thanks.
All right.
Take care, Larry. I'll take it. You'll see me in a few minutes here in an email. Okay.
Very good. Bye.
Take care. Yeah. Bye-bye.